Hello there. So today we are going to cover longest common subsequence. So the input given are two string values, that is text1 and text2, and we need to return the longest common subsequence between these two strings. So let's understand this with an example. Here is our first example. So our string 1 is A, B, C, D, E, and the string 2 has A, B, C. So what are the letters that are being shared commonly by the strings? So let's start from A. Both of the strings have A and B and C. So now the longest subsequence between these two strings are 3 characters, that is the output is going to be 3. Consider a second example. In this case, the common characters that are shared by both the strings are A, C, and E. So what's the difference between previous example and this? In previous example, our string, the substring formed was contiguous. That is, they are in sequence next to each other. But in example 2, it still has common characters that forms a contiguous, that forms a substring or subsequence, but they are not contiguous. It doesn't have to be because they are subsequences. In this case also the output is going to be 3. So how are we going to approach this algorithm? So first, if we are considering to work on it as a brute force, we generate all possible substrings and check which are matching with what, and we calculate the length and finally return the maximum length. So if we are trying to find every possible substring from these two strings, the time complexity goes in exponential. So how do we do it different? So let's get into the solution. So let's consider this example. Let us start having these strings and compare the last character of both the strings. So now they both are same. In this case, we further short down this substrings too. So now, as our last characters are same, they are going to have the common character E, and this steps gives us the common subsequence length as 1. So moving on to our second set of characters, we just cut down one character at both the ends and checking how many characters are matching or what is the longest common subsequence in these strings. These strings can also be written as A, B, C and AC, or A, B, C, D and A. So now these substrings can be broken down into any of this form, that is cutting one character from this end or this string or cutting other character from this string. So we are going to check which of these substrings are going to give us the maximum value or the maximum subsequence. So whichever is maximum, we are going to take the output and going to add it with this one. So further cutting down these problems by trimming the characters at both the ends till we end up with empty strings. And whichever strings is going to give us the maximum value, we're going to add up to the sum already exists and finally arrive at our optimal solution. So how do we do it? How do we check every possible substring with other possible substring? So this is where our dynamic programming is coming into place. We are going to have our integer array dp to keep track of the values we gonna get at each step we compare the substrings. So what does the table actually represent? The table represent or the cell represent a subproblem. Each cell here is going to represent a subproblem. So where our solution is going to be, it is going to be at this bottom rightmost cell. That is, we are going to arrive at our solution here. So for example, if you consider this cell, it is going to tell us, or this is going to be the solution for what are the common subsequence between the string AB and A. Simple. Just randomly check this cell. This cell is going to tell us what is the common longest subsequence from the string A to B and ACE. So let's start filling the values. We are going to fill the values first by understanding why those values are actually going to be in that cell before getting what is the pattern the table is going to follow. So let's start. So now let us start from comparing the empty string and empty string. So both are empty string. What are the common characters are there between them? There are no common characters because there is no string at all. So let's start with filling 0 here. So now moving on to character A, and we compare what are the common characters between the empty string and A. There is no common character. Again, we're going to fill 0. So here at this point, we are going to compare what are the common characters between the empty string and AC, the substring AC. There are no common characters. We're going to fill 0. So same way, we're going to fill 0 at the last cell as well. Same, by filling the column, we have to compare the empty string with substring A and substring AB and substring ABC and then finally substring ABCDE. So let's fill these values as well. So now moving on to this cell, we are going to keep the character A as constant and compare it along with all the substrings from string 2. That is, first let's compare what are the common characters between substring A and substring A. The both are same characters, so we are going to put a 1 because there is one character match. So now moving on to our second cell, we are going to compare the string A to AC. So what are the common characters? Again, they are having common A's. So let's fill in 1. And moving to compare A and ACE, they still have only one character as common. So we are going to fill 1 here. So let's move to the third row. We're going to compare the string AB with A. So what are the common characters between AB and A? It is going to be 1. So moving to next cell, it is again going to be 1 because there is no B in string 2. So again it is going to be 1 because the ACE and AB still shares only single character A in common. So now moving on to our fourth row, that is we're going to compare the substring ABC and ACE. First starting with ABC and A, what are the characters matching? There are only one character match, that is A matches with A in ABC. Moving on to this cell, we are going to compare ABC and AC. In this case, we gonna get 2 in common, that is A and C are matching with this A and this C. In this case, it is going to fill 2. So finally, we are going to check ABC with ACE. So now, how many characters match? There are 2 characters match again, that is AC and AC. So now, if you observe in what pattern the values are filling, you can fill rest of the boxes simply with the values already there for the subproblems. For example, if you consider, they are just going to fill the values by comparing the characters. If there is a character match, then we gonna add 1 with the previous step. If not, the previous step value still stays. Why? Because this is our previous step. Here we have one character in common till this point. If we find any match, we're gonna add a 1 at this point. Otherwise, it is still gonna continue at every other step because we haven't found any other characters yet in our substrings. So considering the pattern, let's fill in the rest of the values in the table. So now starting with this cell, we are going to compare out of which is the maximum. 1 is maximum and the characters A and D are not matching. So it is going to stay with the same value. Moving on to this cell, now we're going to check whether D and C matches. No, they are not matching. So still we are going to stay with the same value in these three boxes, whichever is maximum. So we gonna stay here with 2. So now moving on to this cell, we are going to check which is the maximum value and the characters match or not. Here the character D and E doesn't match. So we're gonna stay with 2 here because that is the maximum of these three boxes. And finally, filling up our last row, we're gonna check whether E and A match. No, E and A are not matching, so we're gonna stay with the maximum value in these 3 cells. So simply I'm going to stay with 1, and moving on to this cell, we are going to check whether E and C matches. No, E and C are not matching, so we are still going to stay with the maximum value out of these 3 cells. So I'm filling 2. Finally, we have arrived at our solution box where we are going to check whether our E and E matches. Yes, there is a match. So out of these 3, the maximum value is 2. And now we have matched one character. So we are going to add 1 to this and our value is going to be 3. So final output of our problem is 3. So if you manually check, it is going to be the same. A, C, E. 3 characters and A, C, E 3 characters are matching in both the strings. So we arrived at our solution at bottom right cell of the TP integer array. As I stressed, every cell represents a subproblem, which actually means it is a solution for the question till that point. For example, just randomly consider this cell. So what does this cell represent? This cell is representing what is the longest common subsequence between the string ABC and the string AC. So if you manually see how many characters matching in both the strings, they are A, C and AC. So it is going to be 2. That is what the box says. So now let's go to our coding part. As I have explained the problem statement with example, so here is our code in Java. You can find this code in my description link, and let's go to the solution. So here, as I said, I'm going to declare an integer array result. This is our DP, which is going to save the solution for every subproblem we have, and we're going to iterate from index 1 to 1 because the first row and first column of our DP was holding zeros. So generally in Java, when you declare an integer array, the default values are going to be 0. So we going to start from the cell 1, comma 1 and start comparing if the character is matched. If there is a match, then we are going to add a 1 to already existing value. If no, there is no match, then we are going to pick whichever is maximum out of the 2 cells. And finally, we are going to arrive at a solution at the last cell of the array. So this is quite a pretty simple algorithm. This actually runs in big O of m n time complexity and big O of m n space complexity, where m is the length of our string 1 and n is the length of our string 2. So let's run. Thanks for watching the video. Thank you.